Hey Jasper, thanks for joining. I'm going to talk about some forum questions here. And so let's talk about this idea of math a little, because I think this is interesting. Someone wanted to try and teach HTM to represent very low level mathematical operations like addition, subtraction, and stuff. I'm a bit discouraging about this, and I was in this post earlier. It is interesting. I think it's interesting to think about, but I don't think this is the direction to go if you want to try and do it the way your brain is doing it. And I mean, this is my opinion, okay? This is not something that Numenta is investigating or anything. We're still trying to understand very high level object recognition type stuff. And I feel like, so let me address this. I said, remember that mathematics is a cultural creation. So the thing that I mean about that is, numerosity is not cultural. Numerosity just exists. And it's certainly possible, or it's certainly probably evident that brains have an ability to identify numerosity, like 3 versus 2 or something. But the concepts of mathematics that I'm talking about, like if you take a number and you operate upon it in this way with another number, it equals another result. That is an idea that is well beyond numerosity. It's well beyond just being able to count. And your point about bees being able to use some, 4 brain cells are enough to count. Yeah, counting's easy. I mean, you can count really easily with computers or with neurons. It's concepts that are hard. It's more than just that. These 4 brain cells, I mean, when you see evidence of numerosity in neurons, it's hard to point exactly to what that really means, what those neurons are really responding to. Each one of them might be responding to numerosity in a specific context or pattern, and like what BitKing is saying, the shape pattern recognition is not math. Yeah, that's what it is. That's more like what he's saying. It's just sort of grouping. It's like saying, if I look at a handful of things, I have a general idea if there's like about 10 things there. I don't even have to count it. There's maybe 20 rocks in my hand. When you look at a jar and guess how many M&Ms there are, you're really bad at that because you have to do math. You have to do math to figure it out. But with very small numbers, you're really good at it. Because humans are really good at counting small numbers, perhaps because we have a lot of small numbers in front of us all the time that we use to calculate with at the tips of our fingers. But very large numbers that takes concepts, that takes movement. Okay, and I mean movement like literally when you're talking about the conceptual space of mathematics. Mathematics is a cultural creation. I say that because it's mimetic. It's mimetic. It's someone had a concept of algebra, and that is a meme that transfers from brain to brain and is taught. It's much more than just being able to recognize numbers. It's performing calculations in a conceptual space, in an abstract space of mathematics. When you learn the multiplication tables, you learn some core rules of math, and you learn how to transform numbers by multiplying them from one space to another. And I think all of these ideas can be tied to location spaces. Like we are always talking about location spaces. Hello, Mr. I wish I knew how to say your name. MSTR Treat. Just Treat. I'll say Treat. What about autistic people who can count hundreds of items instantaneously? They've got something going on in their neurons that lets them do that. I don't know how autistics works. Autism works. I don't think a lot of people do. I don't think we haven't figured that out yet. What exactly autism is, how to treat it, what causes it. So you're saying your ability to do mental math is based on your language? Mr. Treat. All right, that's better. Mr. Treat. I think that's probably true. Your ability to do mental math is based on your language because you're taught math by humans. if you grew up out in the woods and were raised by wolves, you would have a very rough idea, perhaps, of multiplication. But would you ever need to do it out in the world, unless you were maybe were doing agriculture, in which case you might want to do some math. But even then, if you're doing agriculture, you probably learned to do that from someone and they've taught you. So I would say perhaps mathematical concepts are defined in language because there's not much of a physical analogy to these concepts, so you have to define them in language. Some languages don't have words for each number. That's unfortunate. Yeah, so math is a reference frame just like a language is a reference frame, I think. And there's different reference frames have other reference frames in them. So I'm going to talk about reference frames in our next topic too, I think. When we talk about agency. So Strawberry Jesus says, I'm wondering what you're reading up offline. You've talked to Mark about it? I checked the stream recording, but maybe you could repeat what this is what I'm trying to read right now. It's How We Remember by Hasselmo. But I haven't made much progress, but that's what I'm trying to read offline. Jeff suggested it. Great book on the topic is The Language Instinct by Steven Pinker. I've read The Language Instinct. I thought it was interesting, but I don't think that there is an instinct for language. I don't think it's genetic. We're genetically prepositioned for language. So I totally disagree with him there, although I thought the book was interesting. Will we get a book report? Yeah, Hammeroff. Hasselmo, not Hammeroff. Hasselmo. Don't read Hammeroff. Hammeroff will take you way off the deep end. Hammeroff will start talking about chakras and Buddha and, well, depends on how deep you want to go. There's a pill you have to take if you're going to go with Hammeroff. I'm not going to make you take any pills. But no, Hasselmo. Michael Hasselmo. He's a famous neuroscientist, and we've read a lot of his stuff. And this is a great, hate to call it an introduction because it's much more than an introduction. It's way over my head, but there's a lot of great pictures and stuff in here. So if you want to learn what grid cells and place cells and head direction cells and all that stuff, yeah, Hammeroff is the anesthesiologist guy. He studies consciousness. He talks a lot about consciousness, and I went down that trail for a little while. I thought about it. It's Hasselmo. Okay, hold on. Hasselmo? I don't even know how to pronounce it. Hasselmo. I spelled it wrong, sorry. Hasselmo. There we go. The first one was wrong. Okay, sorry, I'm getting off the subject. I wanted to try and address this. Algebra is a lot more complex and abstract. So you're talking about simple arithmetic, but even when you do simple arithmetic, when you say you're transforming a certain count into another count, that's also a mental space. You're doing that transformation in a mental space. Perhaps you can create that space in your own mind and you don't need it to be created culturally. If that's your point, that's fine. I agree with you. It doesn't all come culturally, but any of the high-level mathematical concepts that we deal with every day as humans are definitely cultural, or at least they're taught to you by someone. It's not something you're going to go find out on your own unless you read a book that somebody wrote, you know. I mean, Einstein would not have been Einstein unless he had all of the resources. Standing on the shoulders of giants is the term that you always hear in science, and it's totally true. If all of that, all the work everybody else did and contributed to the memes of science were suddenly gone, we would immediately go back to the Stone Age. And we'd have to work it all back up again, like culturally. Everything we'd have to work back up again. It wouldn't, obviously. Anyway, so simply the lack of sensory feature existence. So we're still talking about empty space again. You do not need to contemplate empty space to perceive that there's nothing in a space. I'm not following this argument very well. Unless the brain can sense it and represent it explicitly. You don't have to contemplate empty space. You don't have to represent empty space. If you're talking about the concept of zero, that's an idea that has its own reference frame in the mathematics reference frame. That is different than empty space. Zero is different than not sensing something. I think we're talking about two different things here. So what I'm proposing, he says, is to associate empty space explicitly to objects that have been recognized. For example, let's say we have trained an HTM doing visual inference and showed it the Numenta cup floating inside an empty room. If the cup wasn't there, nothing would, if the cup wasn't there, nothing would be stored because there would be no sensory input to activate a representation, and that will later be stored. When the cup is visible, this HTM should be able to recognize every object as both the object and an empty room. Be able to recognize every object? I don't understand what you mean here by empty room. Empty room is a concept. It's not an empty room is an idea. It's emptiness is an idea in the same way that zero is an idea. If you're talking, I don't understand where we're getting. This doesn't have anything to do with the lack of, like the sensing of nothing, the lack of sensation when nothing exists to sense. That's, I don't know. I'm having a hard time following it. You can only store the empty room associated with something else, not by itself. Yeah, that's a good point, Falco. The empty room is not just a void. It's a concept. It has walls and a floor and a ceiling. It's a room. You know, if you just said in empty space, yeah, try that thought experiment out. Instead of empty room, just say emptiness. It doesn't work, right? I don't think it works. Jeremy says it seems like the concept of empty space and nothingness are being confused. That's what I believe is happening here too. Mark says there's a class of brain writing where the right has a list of functions. He puts them in boxes and this tries to arrange them in some pattern that makes sense to them. A class of brain writing where the right has a list of functions, puts them in boxes and tries to arrange them in some pattern that makes sense to them. What I've seen is that very few of these match up biological hardware. Right. Yes. Okay, you're talking about like people writing about the brain. Yeah. That's true. That Pinker does that, definitely. You just come up with a list of functions that, I know the brain has to do this, and this, and then try and arrange them in a way that makes sense and turn it into a story. Okay. So if an empty room isn't the commonality, okay, so change this empty room to emptiness or nothing, and then see if it works. Okay, I'm gonna leave it at that. Change this to nothing. Because an empty room is something. I think the main, well, let's just leave it at that, and then I'll post this, and maybe he'll read it or watch it.